So we're going to take a look at the universe today as much as we can and as much as we know about it. And we're going to look at solar systems and components of the universe, and we're going to describe some characteristics of galaxies. I'm going to try to follow your Wix and address the essential questions pretty much in order. Might get out of order just a little bit, but we're going to try to follow as closely as possible to make this as quick as easy as we can. So let's just jump right in there and begin to describe some of the components of the universe. First, we need to define the universe. The universe is all of space and everything in it. That means all of the dust, gas, planets, stars, rocks, everything that makes up the universe, even empty space itself, is what we call the universe. And the second, while the universe is the largest component that we know about, there is the galaxy, which is the second largest component. It is not as large as the universe. It's directly under it, but it's still giant. Galaxies are giant structures that contain dust, gases, and hundreds of billions of stars, all held together by gravity. And you need to define that in your Wix. It's the second item underneath universe. And scientists, while we haven't seen all of our universe, they have estimated that there are over 125 billion known galaxies. Now, that may not sound like a lot to you, but it does to me, especially when you begin to understand just how big a galaxy is. This galaxy is a rendition of our Milky Way, which is not even the largest galaxy in the universe, and yet it is huge. This red dot represents our sun, which has our planets, even the planet Earth. And you'll notice we're kind of on the outside of this spiral-shaped galaxy. It looks kind of like a hurricane. And just to give you some idea of how big this galaxy is, and it contains billions of stars just like our sun, but to give you some idea of how big this galaxy is, I want to tell you that if you could start today on the very outside of our galaxy and travel at the speed of light across our galaxy, it would take you 100,000 years. Now, what vehicle do we have today that would travel at the speed of light? We don't. Just to give you some idea, light travels at 186,282 miles per second. Not miles per hour, miles per second. That's about 670,616,629 miles per hour. Now, I don't know about you, but that's faster than I can wrap my brain around. But just to kind of give you a comparison, our fastest rocket today still travels at under 5,000 miles per hour, which doesn't even compare to this 670 billion miles per hour that we talked about that light travels at. But let's say you could travel this fast. If you could travel this fast, then you could go from one side of our galaxy to the other side, traveling at the speed of light, which we can't do, and it would take you about 100,000 years. Now, that's incredible. And like I said, scientists know about 125 billion galaxies that exist today, and keep in mind, we haven't seen the whole universe. Well, so far we have defined what a universe is. That's the biggest component here. And then the next size down is our giant galaxies, and there are 125 billion known galaxies inside of our universe. And inside of our galaxies, we have yet two smaller components. We have our solar systems and our star systems. Now, star systems come first in your Wix, but I'm going to skip down to solar systems and then define star system. A solar system refers to a star and all of the objects that travel in orbit around it. For instance, our sun has 8 planets and asteroids and comets that all orbit around it. Now, the very end of your Wix, before the action item, it does ask the question, and I want to answer that question now. How does gravity govern the motion of our solar system? Gravity is what holds all of the components of a solar system together. It's what holds the planets in orbit that just, takes the Earth 365 days to go around the sun one time. Why does it stay in a circular orbit around the sun? Well, it's the sun's gravity that holds it in place. I've had students ask me in the past, why do planets and moons orbit around in a circular motion? So gravity is what holds it all together, But why doesn't it all just get sucked into the sun because of the sun's gravity? Well, that goes back to physics. We know because of Newton's first law that an object in motion wants to stay in that motion unless it's acted upon by an unbalanced force. Well, our planet is moving and wants to move in a straight line. Its velocity is to move in a straight line, but it can't because the sun's gravity is pulling it towards itself. So as it tries to move in a straight line, the sun's gravity pulls on it, as it does all the objects in our solar system, and it forces it in a circular path around itself. So while the planet's velocity wants it to go straight, it can't because of the sun's gravity, and while the sun's gravity wants to pull the planet into itself, the planet will not because it wants to move forward. And so you have two forces acting against one another, and as we know, balance forces can result in constant motion, and that's what you get with all of the objects in a solar system that travel in a circular path or orbit around the star, or in our case, the sun. Now, there are some systems that don't have planets. We call these star systems. They're not solar systems because they don't have planets. And as exemplified in this particular image, this is like a binary star system, but it's binary because it has two. But a star system is groups of two or more stars that are held together by gravity, but they don't necessarily have planets. They just include more than one star. Most of the time, star systems don't have planets. Okay, so let's back up to galaxies. We've talked about universe. That's the largest component. We've talked about galaxies. The next one down, it says that the universe contains galaxies. The galaxies then contain solar systems and star systems. And now I want to talk about specific characteristics of galaxies. Galaxies are quite simply classified by their shape. There's three types that you need to know. First is spiral. Looks like a hurricane. Or a pinwheel, as you can see here. There's elliptical. Looks kind of like an egg. It's round, circular in shape. And then you have irregular. And irregular galaxies don't have a definite shape. Now, each one of these galaxy types has characteristics that we need to know about them. And what I'd like for you to do is to turn your wicks over to the back. And in the top half, or maybe 2/3 of the page, I want you to make 3 columns. And I want you to title them spiral, elliptical, and irregular. And I think it would probably be a good idea underneath each heading to go ahead and draw the shape of each one of those. And you can refer back to this image, if you want to know what kind of shape to draw. But I would draw I would write the title and draw the shape underneath it, and then get ready to list some characteristics. Now, I'm going to stop. I'm going to let you guys pause the video, and I think it would be a good idea to set your table up, and then we'll come back and list those characteristics. Alright, so here we go. Let's list some of the characteristics of these 3 galaxy types. Let's start with the most common. The spiral galaxy. About 75% of the galaxies in our universe that we know about are in fact these types, including our own galaxy, which we call the Milky Way. Now, the characteristics of a spiral galaxy are quite simple. They're spiral in shape. They are held together by gravity. Most scientists believe that spiral galaxies have what's called a black hole in the middle of them, and that this black hole creates an immense amount of gravity and holds all of the stars and their solar systems and star systems in place and in orbit around them, much like the sun's gravity holds the planets in orbit. They believe these black holes use gravity to hold stars and star systems in rotation and orbit around them. There is a rotation. So I've already mentioned that. So it's spiral in shape, held together by gravity. There's a rotation. There is a disk. You'll notice on the outside here, this disk-like, kind of like a saucer. And then in the center, you have a big group of stars. This is not one big giant star. It's a big group of stars that are so many and so thick that they look like one big giant light. But it's actually, millions of stars. And they call this central part a central bulge. The halo is this outer glow on the outside that you see. So you have the main disk here, You have the central bulge, and then you have this halo, this soft glow around the outside. Now, one thing about spiral galaxies, there's a lot of dust and gas, and in order for new stars to be born in a galaxy, there has to be a lot of dust and gas. Dust and gas are the breeding grounds of new stars. They're what gives new stars birth. And because a spiral galaxy has a lot of dust and gas, you will not only see old stars, but you will see a lot of young stars as well. So you see both young and old stars in a spiral galaxy. Again, you're looking at our Milky Way. You don't have to write this down. You do have to write these characteristics down, so you may want to pause and write them. This is our Milky Way, and you'll notice the central bulge. They believe at the center of that, again, is the black hole that caused all of this dust and stars to orbit around it. Again, this says what I just said, that the stars surround the galactic nucleus that's at the center here, which some scientists think may contain a supermassive black hole. Okay, let's move on. Before we move on, there's different types of spiral galaxies. You don't really need to know this. You don't have to write this down. But you have the traditional regular spiral galaxy here. But then you have what's called a barred spiral. And that's, you see the central bulge, and then instead of a lot of arms, like the Milky Way has just a lot of arms, this one has two main arms, and they call them bars. And they still rotate and do what this one does. It just doesn't have as many arms, so they call it a bar spiral galaxy. Okay, now let's talk about elliptical galaxies. Again, these are galaxies, they don't have a lot of internal structure. They're older. They're not as young as spiral galaxies. They are oval or round in shape. They do have a halo, an outer glow. A halo is present. That's this outer glow, and a central bulge. They believed at one time that an elliptical was a part of a spiral galaxy, and it had arms, but those have all gone away. So all that's left is the central bulge, the halo, and a lot of old stars. One of the characteristics of an elliptical galaxy is that it doesn't have a lot of dust and gas, so it can't make new stars. There is a little bit of rotation, but it's not as organized as a spiral galaxy. So again, oval and round, held together by gravity. All galaxies are held together by gravity. Central bulge, halo is present. There's a rotation, and again, not much gas and dust, so mostly old stars, not many new stars at all. So now let's talk about the youngest galaxy of all. Elliptical is the oldest. Spiral are kind of like your middle-aged galaxies, and the youngest galaxies are your irregular. These are galaxies that show little evidence of rotation. There's not a lot of organization. They haven't lived long enough to have that organization. There's no definite shape. So I'm looking at the characteristics. There's no definite shape. Sometimes you begin to see the beginning of a central bulge, but nothing that's formed. There is a bit of a halo or a glow because of the light. They're big. They are held together by gravity, and gravity's continuing to help organize them. Lot of gas and dust, so there's a lot of young stars. There can be old stars, but an irregular shape, because it's a younger galaxy, has a lot of younger stars. All right, so those are the characteristics of your spiral, your elliptical, and your irregular. And hopefully what you can do, you can go back and look at the video if you have to, pause it, and write these characteristics down in your wicks. Again, scientists believe that there are over 125 billion galaxies in our universe. This is a picture taken by the Hubble Space Telescope. And these aren't stars, guys. These are galaxies. This is a cluster of galaxies called Draco, and you're looking at about 2 billion light years away from Earth and all of these galaxies, and you can see a lot of the spiral galaxies in there. All right, you do have an action item. Down, again, you were supposed to save some room in the bottom half of the back of your wicks. Your action item is to research our solar system and in our galaxy, the Milky Way. So research our solar system and its location in the Milky Way, and we want you to draw a simple diagram of our galaxy, a spiral galaxy, and indicate our solar system's location. You can do that down at the bottom of your Wix page. Okay, I know this got a little bit long, but I hope this worked for you, and I look forward to seeing you in class.